Hello students and welcome to Lesson 4 of Unit 3. In this lesson, titled Simplifying Algebraic Expressions with Addition and Subtraction of Like Terms, our essential question is, how can I simplify algebraic expressions by combining like terms? And what you are going to see in this lesson is different than what you saw in Unit 1 Part 2 with integer exponents. In that lesson, we were looking at multiplication of different bases. Now we're going to be looking at addition and subtraction of different terms. So you could treat these as this is an additional property on that list for what to do when you're adding and subtracting variables. In our next lesson, Lesson 5, we will combine the two properties. But I just wanted to give you a heads up that this is different. This is dealing with addition and subtraction, where everything else that we've learned about variables has been multiplication. Now, our important vocabulary term for today is the word simplify. It's the first word in the lesson title and the basis for what we'll be studying today. To simplify an expression means to combine all like terms. So in any situation when you simplify an expression, it means to combine all like terms. Even in Lesson 2, whenever you did the order of operation, you were combining like terms because constants or numbers are like terms. Now, to understand how to combine like terms within an expression, you have to understand the parts of an expression, which you learned in Lesson 1. Remember, we've already know that expressions have constants, which are numbers, operations, which signal what we're going to be doing with the constants. They can have grouping symbols like parentheses, square roots, absolute values, fraction bars, brackets, braces, and they can also contain variables. All of ours will contain variables today because we're talking about simplifying algebraic expressions. So today we're going to learn two more parts of expressions, and these parts are parts of both numeric and algebraic expressions, but they're mostly important when you're studying algebraic, and those are terms and like terms. Now, you can think about terms as siblings, and think about like terms as twins. So if you define terms, terms are the parts that are being added or subtracted. If you think about siblings, they're the parts of the family. Like terms are terms with the same variable raised to the same power. So if you think about identical twins, everything about them is the same, or almost everything in our case. So here is an expression, and you can see that it's algebraic because it has variables. And this expression has both terms, parts that are being added or subtracted, and it contains like terms, two types. Let's first start by looking at terms. And let's try to decide the number of terms there are in this expression. Now, to figure out the number of terms, you cannot just count the add and subtract signs. Because think about it. 2 plus 3, very basic expression. It has one addition symbol, but it actually has two pieces being added, two parts that are being added. So if we look at our expression, we cannot count addition and subtraction signs. We need to count what's in between them, always grabbing the sign in front, because all the sign in front does is tell us whether it's a positive or negative amount. So here's our first term, 7x, our second term, plus 3, our third term, positive 8x, our fourth term, positive x squared, and our last term, negative 7. So there are 5 terms in this expression. Now, the ones that are alike are the terms with the same variable and the same exponent. It has to be both. So for instance, we see the variable x, both here and here. But these two are not like terms because they do not have the same power. They do not have the same exponent. This expression's variable has an exponent of 1, whereas this term's exponent is a 2. So these are not like terms. Yes, they have the same variable, but they do not have the same power. Can you find any that have the same variable and the same power? Here are the two, 7x, and notice I'm grabbing the sign in front, positive 8x. These are the two that have the same variable, x, and the same power, 1. Now there is also a second set of like terms, and that is your constant. These two constants have the same variable. They don't have one, and it is to the same power. It doesn't have one. So you can see that constants are also like terms. Now, let's discuss another vocabulary word, and that is a coefficient, because this is a term that does trip some people up because they start to connect to the multiplication properties. So, let's talk about what a coefficient is. A coefficient is a number multiplied by a variable. So for instance, in this expression, there are 3 numbers being multiplied by the variable. Do you see how this says 7x? That's 7 times x. So 7 is a coefficient. Here, with our other variable, we have positive 8. Positive 8 is a coefficient because it's being multiplied by x. Now notice we have one more variable. Although there is no number written here, it does have a coefficient. Think about it. Plus x squared. How many x squared is there? 1. So positive 1 is a coefficient. So what I just explained to you was 7, 8, and 1 are the coefficients in this expression. Now, some of these are like terms. 7x and positive 8x, they are like terms. Notice, like terms can have different coefficients. Like terms is not in any way affected by the coefficient. Like terms only means same variable, same exponent. Has nothing to do with coefficients. So like terms can be different coefficients. And the last thing you learned in this example was a number written without a coefficient has a coefficient of 1. And for some of you, it's beneficial that when you see a variable and there's no coefficient written with it, go ahead and write that number 1 right with it. Now, let's look at how we can use these properties to simplify like terms. Our first step in simplifying like terms is to identify like terms. So our first step is ID like terms. Personally, I like to use shapes like squares, circles, and underlining. That kind of looks like a face. I'm not mad. To identify the like terms. Now, if you look at our expression, we can identify some like terms by looking for same base, same exponent. So I like to start at the beginning. Alright, so I have 6x. This has a variable of x and an exponent of 1. Are there any other terms in this expression with a variable of x to the first power? And the answer is yes. Here we have negative x, which we just learned means negative 1x. And here we have x to the first power in the term positive 2x. So these 3 terms can be combined together. 6x take away 1x is 5x. Add 2 more x and you get 7x. Now notice, this term with x squared does not have any other terms like it. That's fine. Just write it down beside or at the end of your expression. Now this is your simplified expression. You cannot combine these two because they are not like terms. Yes, they have the same variable, but they do not have the same exponent. This is the simplified expression. All right, let's look at another example. We have 12t plus 8t plus q minus 7t. So as we talked about in our last example, our first step is to ID like terms. We didn't write it down, but we did do the second step, which is to combine them using addition and subtraction of coefficients. If you want to write that down in your notes, you can. Now, let's first start to identify like terms. I like to start at the beginning. So we have 12t, that's t to the first power. Are there any other terms with t to the first power? Well, we have plus 8t. Notice I'm grabbing the signs in front because that'll tell me whether to add or subtract. And negative 7t. So then start combining them. 12t plus 8t, and you can even write them on the side if you need to. 12t plus 8t makes 20t. Minus 7t is 13t. So you have 13t, and then notice there's no other terms with the variable q to the first, so we put plus q. Students, start to learn to put a tail on your t in mathematics class, because if not, it looks like a plus sign sometimes. Side note. Alright, let's look at another example. First step, identify your like terms. We have 3a plus 2a squared minus 3 plus 6a minus 4a squared. I like to start at the beginning. Some people also like to start with the highest exponent, and that's fine too. Let's do that in this problem, just to show you a different way. So we have positive 2a squared. Take away 4a squared. Well, what does positive 2 have 2 and negative 4 make? 4. Positive 2 minus 4 makes negative 2a squared. Notice the variables do not change in addition and subtraction. Well, if we continue looking, we have 3a and positive 6a. So if you have 3 and you have 6 more, you have 9a. And then last, we have a constant, and there are no other constants, so we just bring that down. And this is our simplified expression because none of our terms have any that are similar to them. Let's look at another example. We have x squared plus 2x to the fourth minus 8 plus 9x squared plus 2x to the fourth minus 6x squared. Very long expression, has 1, 2, 3, 4, 5, 6 terms. Now, I want to also show you that with a very long expression, when you're thinking about how many terms, you can also decide how many your answer will have. So if you start marking your like terms, we have x squared and positive 9x squared and negative 6x squared as like terms. We have positive 2x to the fourth and positive 2x to the fourth, which are like terms, and we have negative 8 as a constant with no other terms like it. Do you see how I've used 3 symbols to mark my like terms? That means that my answer will have 3 terms in it. So if we combine them, positive 2x to the fourth plus 2x to the fourth makes 4x to the fourth. 1x squared plus 9x squared makes 10x squared. Minus 6x squared makes positive 4x squared. And then our constant at the end, minus 8. In part 2, we will do a few more examples and summarize what we've learned.